Morning, Algebra 2. Let's get going. Unit 4, day 4. Feel free to pause the video, fill in these blanks, read through that at your own pace. Let's move on. Make a table of values. Graph f of x equals x squared. This is the parent function of a quadratic. And I'm going to start by giving you the plots that you would want to plot in order to graph this. And then I'll explain it. All right. So here we have the ordered pair -2, 4. Here we have -1, 1. Here at the origin 0, 0. Right there, that is 1, 1. And right there is the ordered pair 2, 4. Now I want you to notice something because it's going to make graphing quadratics much easier if you know what the vertex is. And this trick will work for today. There's exceptions. And if we get to those exceptions in further lessons, I will point that out to you. But for today, this trick will work. As long as you know what the vertex is, you can plot the other points by following a pattern. If I go right one and then up one, that gives me to my very next coordinate, my very next point, or even here, left one, up one. Now here's the pattern, right one, and then 1 squared is 1. So I go right one, I square the number 1, and that tells me how many I then need to go up. To get to that point here, I need to go right 2, and then if we take 2 and square it, that gives us 4. So once again, right 2, and 2 squared is 4, so that tells me to go up 1, 2, 3, 4. Now, if we had to plot another dot, I would want to go right 3 spaces from the vertex. And now how many would I need to go up? Well, what is 3 squared? 9. So you go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and you put another dot. It follows that pattern over and over again. Here, is there a minimum or maximum point? If so, give the ordered pair. Now, I'm not going to give it as an ordered pair. There is a minimum. In order to have a minimum or maximum, you're looking for, is there a point there our graph will never be any lower or our graph will never be any higher? In this case, this graph will never be any lower than that point right there. So that is referred to as a minimum at the y value of 0. It will never go any lower than where y is 0. Does this graph have a vertex? Yes, it does. Right there. That is where this graph begins. And that ordered pair is 0, 0. Your vertex is where does your graph begin? How would you describe the symmetry? We're going to answer that question here with D. Draw a dashed line of symmetry. So our line of symmetry is going to split the vertex right in half. And right there. Your axis of symmetry is going to split the vertex right in half, making opposite sides of the vertex symmetrical. Now the axis of symmetry is an equation. And the equation is, well, where is that vertical line going through the x-axis? And it's going through the x-axis at 0. Therefore, the axis of symmetry is x equals 0. List the domain and range in interval notation. Well, your domain for all quadratic functions, which is what we're graphing today, is going to be negative infinity, positive infinity. And remember, domain simply refers to how much of the x values will our graph cover, and this graph is going to continue expanding left and right forever. So we're going to cover all the x values. Range means how many of the y values is our graph going to cover? Well, it's never going to go any lower than this. And this is where y is 0, but it will continue going up from that point forever. So our range is from where y is 0 to positive infinity. All right, let's take a look now at example A. We have to graph this function and it gives us the vertex. So let's start by plotting the vertex. Right 1, down 1, 2, 3, 4. Now, don't even worry about filling out this chart. There's going to be a point in time where filling out this chart is going to make graphing easier, but with quadratics, we can just follow the pattern that I just showed you, as long as you know what the vertex is. So from here, we're going to go right 1 and then up 1. Why did we go up 1? Well, because if we go right 1, then square 1, and that tells you how many you need to go up. Now for our next dot, let's go right 2 And then how many do I need to go up? What do you think? 4. 4. Because if we go right 2 and then take the number 2 and square it, that tells us how many we need to go up. 1, 2, 3, 4. Okay, go back to the vertex. Now go right 3. What is 3 squared? 9. So now go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you could do the same thing on the opposite side of the vertex. Go left 1 and then square that. -1 times -1 is 1. Go right 2 and square that. Left 2 and square that. -2 times -2 is +4. Go left 3 and square that. -3 times -3 is +9. Here they want you to factor this. I'm going to factor very quickly this one because we've been factoring. This is now the 4th day of factoring. We need the factors of -3. Let's subtract to get 2. There they are. Since our leading coefficient is 1, you can go ahead and plug them right into factored form. X plus 1, x minus 3. Now, as I mentioned, this is day 4 of factoring. Here's what we're going to do today that's a little bit different. We're not just going to factor. We're then going to solve them. Oops, I don't need mine. Let me start over. In order to solve once you factored, just take your factors and set them equal to 0. I took what was in parentheses and set them equal to 0, and then we solve for x. So here you'd have to subtract 1 from both sides. Here you'd have to add 3 to both sides. What do you notice? Well, look at our graph. We have x-intercepts at -1 and +3. That's what factoring and solving tells you. It tells you what are the x-intercepts without the need to graph. This one, let's start by plotting our vertex at -3, -1. Left 3, down 1. Now let's do that trick. Right 1 and then square 1, up 1. Right 2 from the vertex and now square 2. That would be 4. So up 4. 1, 2, 3, 4. And we're going to stop there because the other one wouldn't. If we went right 3 and then up 9, it wouldn't fit on the graph. Let's go back to the vertex. Left 1, -1, and then square it. -1 times -1 is 1, so up 1. From the vertex, go left 2 and then square it. That would give you 4. So go up 1, 2, 3, 4. All right, now we're going to factor this. We need the factors of 8 that can add to get 6. Our leading coefficient here is 1, so we can go right to factored form. Let's set these equal to 0. And now solve. And now we have identified what our x-intercepts are. At this point, please pause the video, fill in these blanks, read through it, and then I think it will make sense. Let's now move on to example A. Solve by factoring out the greatest common factor. So we have 3x squared plus 6x. Think of this as group 1. What can we factor out of group 1? Well, that would be 3 and x. Open up a set of parentheses. And if you divided group 1 by 3x, that would leave you with x plus 2. We have now factored, so you're going to set both of your factors equal to 0, including the 3x. By solving this one, we would have to divide both sides by 3. 0 divided by 3 is 0. That's one of our x-intercepts. That's one of our solutions. Here you would need to subtract 2. So our solutions are 0 and -2. We have now solved. Example B, Our leading coefficient is negative, so we need to factor out the negative. 2 and 8 are both divisible by the greatest common factor of 2, and x squared and x are both divisible by the greatest common factor of x. If you divided both of these terms by negative 2x, it would leave you with x minus 4. Just want to double check. Yep. Now, set each of these equal to 0 and solve. This one, add 4. This one over here, divide by negative 2, and 0 divided by negative 2 is 0. We have now found our x-intercepts. We have now found our roots. We have now found our solutions. We have now found our zeros. All those terms mean the same thing. Example C, well, we have a problem with example C. We need to combine like terms here first. 4x squared minus 6x squared is negative 2x squared. Now the other problem is this equation is not set equal to 0. So you'd have to add 12x and bring it over here. Now it's set equal to 0. And now we can factor out the greatest common factor, which would be negative 2x. Open your parentheses. Negative 2x squared divided by negative 2x is x. 12x divided by negative 2x is negative 6. Now set your factors equal to 0 and solve them. Divide by negative 2. 0 divided by negative 2 is 0. Here add 6. X equals 6. We have found our zeros, we have found our solutions, we have found our roots, we have found our x-intercepts. Example D, we are going to solve the quadratic trinomials by factoring. What we want to do is f of x, which is a fancy way of saying y, we want to set that equal to 0. That's how you solve these. You want to set them equal to 0. And then if it's a quadratic trinomial, let's factor. Let's see if we can factor it. Number in front, 1, times number in back, negative 15. That means negative 15 goes on top of our t-chart. Here's all the factors of 15. If that number on top of your t-chart is negative, that means these factors must subtract to get the middle number here. 15 minus 1 is 14, so get out of here. 5 minus 3 is 2. Those are the ones we need. But more accurately, it needs to be negative 2. So this needs to be positive. That needs to be negative. 3 times negative 5 is negative 15. And 3 minus 5 is negative 2. So we have the right factors. The leading coefficient is 1. So we can plug this right into factored form. These are equal to 0. Okay, now take what's inside your parentheses and set them equal to 0. That one is done. Example E. Well, there's a problem with example E. First of all, it's not set equal to 0. Let's fix that. You're not going to trick us, E. And then, oh, look at this. It's not in the right order. We've got to put this in the correct order. Negative z squared plus 5z plus 24. There we go. That's the right order. And now that it's in the right order, we can tell, oh my goodness, we have a leading coefficient is negative. So we have to factor out that negative. And by factoring out the negative, it's going to flip all the signs. Now looking in the parentheses, you want to see if we can factor again. Let's see. Number in front times number in back. 1 times negative 24 is negative 24. There's all the factors of 24. Since that number is negative, it tells us they must subtract to get the number in the middle. So we're using 8 minus 3. Or more accurately, since that's a negative 5, we're using 3 minus 8. Leading coefficient is 1. Thank goodness. Let's just save ourselves some time here and some mental energy. What am I forgetting? Oh, I'm forgetting the negative. Don't forget we factored that out too. And then we have to also solve. You want to put this equal to 0 too. You're technically supposed to do that. That is a negative 1 equal to 0. Set z plus 3 equal to 0. Z minus 8 equal to 0. Negative, now start here. Negative 1 equals 0. No, it doesn't. So that's not a solution. Z plus 3 equals 0. Well, this can be solved. And now we have our solutions, negative 3 and 8. Example F, not set equal to 0. I prefer my a term, 3b squared, to be positive. So I'm going to add 14b to that side. I'm going to add 8 to that side. And by doing that, here's what we're left with. 3b squared plus 14b plus 8 equals 0. Okay, now we can factor and solve this. Number in front, 3 times number in back, 8. Positive 24. If that number on top of the t-chart is positive, that means your factors must add to get the middle term. So we have to be using 2 and 12. Since that's positive 14, then, well, these both must be positive. Also, if that number on top of your t-chart is positive, that means your signs are going to be the same. Plus plus or minus minus. Warning, your answer is not b plus 2 and b plus 12. There's now a number in front of our b squared. So we have to create a grouping problem. Start with 3b squared. Now substitute your factors and give them a b. And then end with plus 8. And I'm not going to worry about the equals 0 for right now. Group 1, group 2. We're about to factor by grouping. Out of group 1, we can factor out a b. And if you divide group 1 by b, that leaves us with 3b plus 2. Group 2 looks like we can factor out a positive 4. And if you divide group 2 by 4, that leaves us with 3b plus 2. b plus 4 is one of our factors. And 3b plus 2 is the other. Now I'm going to set these equal to 0, and then we can figure out what our answers are. I bet y'all figured these out right here. These are pretty easy. One of our solutions is negative 4. This one's a little bit different, though. Let's subtract 2 from both sides. And now you have to divide away the 3. Leaving us with negative 2/3. Those are our final answers. Example G is not in the, it's not set equal to 0. So let's subtract 11m and bring it over there with its buddies. What a terrible arrow. Okay. 5m squared. We subtracted over 11m plus 6. And now our equation is set equal to 0. Number in front, number in back. More technically, it's a times c. 5 times 6. Positive 30. That number on top is positive. which means your numbers, your factors have to add to get the middle term here. It also means your signs are going to be exactly the same. In this case, both minus, minus, minus. We have to factor because we have to factor by grouping because there's now a number in front of m squared. So 5m squared. Let's substitute our factors here and give them a m. I'm not going to worry about the equals 0 for now. Group 1, group 2. Out of group 1, you can factor out a 5m. And if you divide group 1 by 5m, it leaves you with m minus 1. Group 2, you can factor out a negative 6. And if you divide group 2 by negative 6, that leaves you with m minus 1. There's our factors. Now let's set them equal to 0. And solve them. That's one of our solutions. Let's find the other one. Move on to side 3. Okay, write this down at the top. Does not factor. A prime quadratic equation is one that does not factor. Example H. Well, the 11x is on the wrong side. Let's subtract 11x. Bring it over there. Okay, now I'm going to create my t-chart, which is pretty much what this is. It's just a fancier t-chart. A times C, 7 times negative 2 is negative 14. 1, 14, 2, 7. Now what that negative means on top, it means these are going to be different signs, and we have to pick the factors that subtract to get 11. 14 minus 1 is 13, so we're not using those. 7 minus 2 is 5, so we're not using those. Oh my goodness, this cannot be factored. Therefore, your answer is prime. If they want you to simply factor a problem and you cannot factor the problem, then it is prime. If they want you to solve and you try to solve by factoring and you can't, that doesn't mean your answer is prime. If they tell you to solve, that means you're going to have to use a different alternative to solve it. Factoring won't work, and we'll get to that in a later lesson. Okay, here, example I. If we were to try to factor this by, let's say, a times c, that would give us negative 20. These are all the factors of 20. Now, remember, a quadratic consists of an a value, a b value, and a c value. You identify the a value by looking in front of x squared. So our a value is 1. You identify the b value by looking at the number in front of x. But we don't have an x. Therefore, we do not have a b. And our c value is the number without the x, negative 10. So here's what we need. We need the factors of 20 that subtract to get 0. None of these subtract to get 0. Therefore, this one cannot be solved by factoring. This is also prime. And guess what? If you did the same thing there, it'd be prime. I'm not doing that one. Have a good day, everybody.